All right. My name is Pierre Olsson. Welcome. And I work at Struisoft, which is a company that does structural design software and also energy. My background is from here, VSMN 1994, so 30 years ago. So it's been a while. I actually attended this particular course as well back in the day. After my dissertation here, I did my PhD at Chalmers in civil engineering regarding user interfaces, finite element calculations, and programming in general as a cross-disciplinary project between civil engineering and architecture. And after that, I started working at Struisoft. I've been there for 17 years now. I'm the team leader for application of structural design. So that basically means that the application that you will use as a structural engineer for designing your concrete beams, your steel beams, or your columns, and all kind of different element-based products, if you will. Columns and beams and frames, most likely. That's basically me. So let's start a little bit to talk about about Struisoft. Struisoft has actually started in Skanska way back in the 80s, and around 2002 the company Struisoft actually emerged and was bought out of Skanska. And after that we've had our own history, and recently we have partnered with, we were actually bought by a Norwegian company called Vind, which buys up different kind of technology companies, basically. So we have like brother and sister companies that does the same thing as Struisoft does, but in other countries like Netherlands, Belgium, and Australia, actually. And we have our main market is, as you can see, the Nordic countries, basically. That's where we have almost I'd say in Sweden we almost have a monopoly on these 2D design tools, more or less. They're called WinStatic, and it's not from winning, it's from Windows, because they're so old. That is what actually a advantage to call the program something with Windows in it, Windows in the name. So it was the first Windows programs that was created and sold as a Windows program in Sweden, actually. So long history. And we have offices. The main office is in Malmö, in Hyllie. And we have also in Stockholm and Gothenburg and a couple of other countries, mostly Denmark, but also all the way across the globe, almost, as you see here. And the portfolio is, as I said, structural design software in general, but also energy, such as calculating the amount of energy needed for keeping a warm house, basically, have enough insulation and whatnot. So if we take, these are the main big program suites. The first one is called Impact. It's actually for the precast industry. And it's not really a calculation program. It's more of a planning tool. All the way, you can say it's a BIM tool, more or less, for companies or factories that does precast concrete elements, basically, like hollow cores or wall elements or beams and columns as well. So it's about planning those all the way from the initial project planning all the way through the erection sequence of where to build it in the factory, in what order it goes on the truck, when it should be delivered at the site, and when it actually is used in production. And it's you can extract from it the plans, basically. So if you say I'm going to build this hollow core, you can like right click on it and you can get your plan. So you can put it in the hand of the people that worked in the factory. Okay, we need to build this wall. Okay, here are the plans, and there's a whole connection in like a big database, basically. And then we have FemDesign. Diamonds is an equivalent that is sold in Belgium. FemDesign is exactly just that. It's a tool for doing finite element structures, basically. Not really that much for elements. It's more of building the entire structure and see if you apply the loads, like the snow and the wind load, and you want to see, okay, what are the loads, or what are the forces acting on each individual elements, basically. You can do a design check according to code, like for steel, timber, and concrete. But it's mainly used for calculating the way the loads go all the way down to the soil, basically, and also including in the soil. And you can do a lot of stuff. That's our biggest program, I would say. It's almost like a CAD tool, like a design tool. And then we have the two-dimensional, the element design programs, which are the ones that I'm responsible for. So WinStatic we mentioned, and there is an equivalent in Finland called Jiggy, and one in Denmark called Dimension. So it's basically concrete beam, concrete column, core bells, as you see there in the pictures, foundations, what have you. And the most important part is maybe not the finite element calculation. It's more of, is this according to code? So like Eurocode for now. There is a second generation Eurocode coming now, but that's basically the building standard that it is compared to. So that's a very important tool for a structural engineer, saying, okay, this I've created this concrete beam. Okay, but is it according to code? Do you have the report for it? Do you have the math to back it up? So that's what that's kind of tool that we supply the engineer with. And then we have pre-stress, which is basically an offshoot between Impact and WinStatic. It does basically beam calculation, but it's particular for precast or pre-stressed, I should say. So having a pre-stressed tendons that you cast in. So that's a very, very specific tool, but it's basically a concrete beam tool. And then we have the last suite, that's Beam Energy. There are like two offshoots of that. One is called evaluation and one is called renovation. The evaluation basically says, okay, I have this house. I'm saying, okay, it's like 2 stories. It's poorly insulated. Okay, what kind of energy is required? How much do I require over a year, for example? So these are like a proper calculation at the bottom, but it starts up with a lot of templates, which actually hit home pretty easy. I modeled my own house with just a couple of clicks and came very close to what it said on my bill. So that's pretty interesting. And you can make a change. Say, okay, I'm going from a poorly insulated house to a medium insulated house, and you can see what kind of impact that has on the energy consumption. So that's a good way to gauge, okay, am I going to do this change or not? Because it costs a lot of money, or this is a low-hanging fruit. Okay, I'm going to do this because I have a lot of advantages for such a small change. And taking that further is the twin sister, which is called renovation, which basically does the same thing, but it also focuses a lot of, you probably heard energy classing now on buildings. They are like A is the best, and then you have B, C, and whatnot. And you can get cheaper insurance if you have a good class on that and that kind of stuff. So that program kind of helps you figuring that out. And it can also take a bigger, you can point on a map and say, okay, these blocks are mine, and I want a assumption of how much energy consumption I am using for these buildings, and it kind of reads the map and say, okay, how high is it? And then it does all this modeling and gives you a value. So that's more of a for what would you call the ones that owns the buildings, for them to know, should we go ahead and change all the windows in our building, for example. So it's a tool for gauging that kind of stuff. So mainly used for like local communities, whatnot. Maybe not private persons. That's more evaluation. All right. So this is the portfolio of what we have. So I wanted to kind of explain what we do and how we work, because I think that's the interesting part for you guys, knowing what would it be like actually working with doing one of these tools or keeping them up, because it's very similar to what you have done in this course. So, okay, a little bit more about how we are structured. It's maybe not that important, but basically we have different business units with like energy, structural, and whatnot. And there's a top person, which is the business unit manager, and then we have all the developers, so front end, back end, UX, and then senior advisors. That's more you guys, including myself. It's kind of a mix of the two in the middle, more or less. Some drop down to the last one as well and do some sales and support and marketing. But these are basically the people that are involved in the company within the company. And how do we work? Let's say it's pretty similar for the desktop applications we have and also for the web applications we have. So if you would be a part of such a project, you would probably start by making sure you have a roadmap where all are involved and have their say in what are we going to do. And after that, we probably sit down and do like user stories. I want to design this beam and I want to know how much CO2 it's consuming, perhaps. That will be a user story. And then you do technical specifications based on that, and that's pretty much what you do in the analysis part in your program. And also a lot of stuff mostly pertaining to code checks. And then once you have your planning up and running and you have your goal, then it's like the reoccurring cycle, which is, I want to say Scrum and Agile because it's a buzzwords, at least it was a while ago, but I'm not going to go too much into it. I'd say we try to do short iterations, like these are the goals we have for these 2 weeks, and that's our goal right now. We don't think further than that at this stage. And we try to keep small teams. So we have like an engineer and we have a programmer and we have like a UX designer and both front end and back end developers. So we have like a fast iteration. If you have a question, you don't have to put it in your mailbox and send it to some other department that needs to get to it when they get to it. We have kind of a fast turnaround of that particular task. And I'd say from that point of view, it's an agile development. And the short iterations is basically divided into sprints. And sprints are like, maybe we have like 2 week sprints, for example. And we say, okay, within these 2 weeks, we're going to do these tasks. And then we assign this task to the developers in the team. And we try to say, okay, this task is going to take 16 hours maybe, and this one takes 8, this will take 1, this takes 32, whatever it is. And then we try to patch it up with the resources we have, and we say, okay, this is what we're going to do. And then we have like a weekly, how is it going thing, and also a daily stand-up at the morning. We say, okay, what are you going to do today? I'm going to do this. Okay, what you're going to do? And it gives everyone a chance to kind of chime in and say, okay, I have an idea that you could maybe test there, and okay, I need to do my stuff first before you can go on, and that kind of stuff. And the tasks can be named a lot of stuff in these methods. Cases is one way to call it. I think GitHub says issues, doesn't really matter. It's like a task, and it's being divided into what is this being decided for the sprint. This is what we're going to do, and then of course when you start working on something, you put it in progress and you start working on it. And then when it's done, you put it in awaiting, and then someone will test it and so forth, and then the cycle goes on and on. So these are the methods, basically, and I'm pretty sure that you will all meet something like this if you would start to work as a developer in some sense, I would say. And when it comes to tools, I'd say most likely you will touch upon many of these as well, regardless of where you get. We use Trello, Fogbox, and GitHub for case handling or issues or tasks or whatever. And for development, Visual Studio or the IDE, Visual Studio and VS Code. And I know you use VS Code in this project, I believe. So you're familiar with it. So, from our point of view, we have mostly C and C++ code, a lot of C#, not a lot of Fortran, but there's a little bit of it. There's some Delphi, and of course a lot of JavaScript. But I'd say most of us just come in with whatever it is we know, because the syntax is more or less the same. It's just, how do I do a for loop in this language? So it's not really that important saying, I'm very good at C#, I cannot do JavaScript, because that's not true, basically. And for user interfaces, we use not a lot of Qt, but some of it. I think you use that one here as well, right? Yeah. And we have for the old desktop program, we have MFC, which is Microsoft Foundation Classes, old library, and VPF for C# applications, and React for JavaScript application. And for scripting, Python, which I assume you all are familiar with by now, and also ANSYS, which is being phased out. And I'd say using Git for code handling is something you will have to be familiar with, regardless of where you end up working with software development. So that's a very good thing to know and be familiar with. And I'd say after we are ready with our code and we want to leave it to the next step, we will be building the artifacts, the installation programs, or deploying the websites. We have a development operations department, DevOps for short, at Storysoft, which helps us with the last step, which is basically taking the code and building it, creating artifact, distributing it, and if it's a web page, it will also deploy it, like giving it a URL so you can reach it. So that's basically the tools we are using. I think maybe half of them would be pretty generic, regardless of where you end up, but I think there will be something similar. Maybe different tools for different tasks, perhaps. Let's see. So maybe I should talk a little bit about what we're doing currently, and maybe touch upon how it would connect to what you guys have been doing. So we are trying to go away from the desktop applications towards web applications in general. And we did like a market search, and it turns out that a lot of, at least the younger engineers, want to have more control over their situation. So typically they prefer, I wouldn't say prefer, but it's more and more apparent that they want to have access to an API and do their own script for their own calculation, rather than use an established UI that has been the same for years and years. So in line with that, we started to take all our calculations and put them behind an API, and then you could be free of any old user interface, because that will be the division, and I think that will be like your model space in your projects, more or less, since you have separated the visualization part and the UI part. So we started to do that, and it lent itself very good for doing web applications. So we started to experiment with that. So this is our pilot project, which is just a beam application. So it does analysis, and it does code check for steel, timber, and concrete. So it's a pretty simple setup, but it kind of touches upon all the ingredients that it needed for most element design tools that are required for most engineers to work today. So this is written in React, and the backend is different APIs connecting to C# code, C++ code, and indirectly some Fortran code. So as you saw, the big program we mentioned earlier, FemDesign, has been ported to have a cloud solution to which we are connecting this app, for example. And that is from the structural design side of things. And this is evaluation, beam energy evaluation. So this is written in the same toolkit, and it has the same type of backend, meaning the calculation core exposed as an API, and then you have a client, which is the front end, the web page, talking to the backend, basically. So this is also React. It shows a little bit about what I mentioned. This has a clear start and end. You start from the left and you go all the way over to the right, and there's a lot of default values. So as soon as you do create project, you already have a result, which is pretty good. It's like almost get like a lump of clay. You have the result. You can just change it. Okay, I don't want this. I want another type of wall. Okay, and then you can see here at the right, it says in Swedish though, energy needed and energy supplied. So you can see how that, what is it called? Pie charts. It kind of get the different sizes regarding of what changes you do, like direct feedback. So that's the front end, and for the back end, I think this is maybe you could say that it kind of have the same generic setup as the programs that you have been creating, with your client being your UI, and then you have like a middle layer, which will be like the analysis service in this case, which basically handles your model data, and then it does a call to the analysis, and it gets results back, which is then taken out all the way out to the client. So this is basically the setup that we have for all our different kind of aspects. We have a lot of different APIs for analysis, for concrete design, for timber design, steel design, assets database, meaning sections, materials, and whatnot, and also direct question regarding Eurocode, like load combinations and load factors and all that kind of stuff. So it becomes like a palette of APIs that you can use to build your app. So what we have done is we have created a few apps, but the idea is to expose all these API as something that you can buy into as a user. You can create your own applications from that, or just scripts. If you want to just do like an parameter study or something like that, for example. All right. Did I have anything else? No, I didn't have anything else. So that was basically my presentation of how it is to be working at a company doing the stuff that you have been doing in this course. I didn't really have that much else to mention. I will gladly answer any questions you have regarding of what we do and what kind of people we are, what projects we're doing, and how it is doing this, and if you have any questions. Yeah.
Du har inte tid att visa alltså något av programmen där du gör en balk och visa vad man kan få ut och så. Kan du göra det nu?
Om jag kan koppla upp min egen dator.
Ja.
Jag kan testa.
Tryck
du har
paus då.
Paus.